This video is part of a series of video instructions on the BioGrace greenhouse gas calculation tool. This is instruction 2.4, how to make actual calculations and apply user-defined standard values. Actually, there are two BioGrace tools. There's BioGrace 1 for biofuels and BioGrace 2 for electricity, heat and cooling from biomass. All information is accessible through www.biograce.net. The instruction will show the BioGrace 1 Excel tool, but can also be used for BioGrace 2, as in the BioGrace 2 Excel tool the calculations are made in exactly the same way. For making actual greenhouse gas calculations, you need a methodology, data from the process, numbers or coefficients to convert these data into greenhouse gas emissions, and data or numbers for the reference process. This video instruction 2.4 is on point 2, data from the process. First, I will show you how to replace input numbers and then how to apply user-defined standard values for inputs not included in the list of standard values. Imagine that you are a farmer or someone working for a farmers' corporation in Flevoland, which is a province in the middle of the Netherlands. You want to make an actual calculation for sugar beet cultivation. You will have to start with collecting all the data that you need from measurements at your farm or at your corporation, or from agricultural statistics within the province. These are the numbers that we will use. One important number in the calculation is the emission of N2O, also called nitrous oxide or laughing gas, from the field. This is not often measured and you will need to calculate it. This will be shown in a separate video instruction. In the present instruction, 6.2 kilograms N2O per hectare and per year will be used. Another important aspect is that the units of the numbers should be the same. I will check the units that we collected versus the units in the BioGrace sheet, which I open here as a small box so that we can see both at the same time. The yield of sugar beet is in kilogram per hectare per year. This is fine in both lists. The diesel is in megajoule per hectare per year. Fine too. The nitrogen fertilizer is in kilogram nitrogen per hectare per year. The same for both lists too, etc. If one of the numbers would have a different unit, then of course you should convert the number in the list of numbers that you collected into the unit that is used in BioGrace. Now I can insert the numbers that we collected into BioGrace. Before doing so, let's remember what is the result without the changes. It is 11.46 grams CO2 equivalent per megajoule ethanol for the cultivation. Now I will replace the numbers like this and this. I will do it a bit quickly. You can now see that the overall result of the cultivation is 9.99 grams CO2 equivalent per megajoule ethanol. So the emission is reduced by about 1.5 grams CO2 equivalent per megajoule. Please note that when I inserted the numbers, the cells in which I have done so changed background color, obtained a red box around them, and now contain a comment box. This is because track changes is on. You must leave this on if the calculation is made to be checked by a verifier, as a verifier shall refuse to verify the calculation if track changes is turned to off. I will come back to track changes near the end of this video instruction. First, I will explain how to include user-specific standard values. Let's make the example a bit more complicated. I return to PowerPoint, and let's assume that 1. We actually know that the synthetic nitrogen used was urea, and 2. We have used some electrical machinery and have used 134.5 megajoule electricity. Now you will have to do the following. First, check whether the inputs urea and electricity from the grid and L are in the list of standard values. You open the list of standard values and scroll to all materials in column C. Your conclusion is not included. Then you will open the list of additional standard values and do the same. There you will find urea. You see it listed here at the lower end of the part of the list that is visible here. Electricity NL is also included, so the conclusion is included. If 1 or 2 of the input values would not have been included in the list of standard values, nor in the list of additional standard values, then you would have to look for emission factors yourself and include these numbers in the user-defined standard values sheet. You should make sure that this is reliable information. For this, please refer to BioGrace calculation rule number 2.2.1. If so, then these data can also be used. Now I will show you how you can apply these numbers. We go back to the tool and make it larger. Via the directory you can enter the list of user-defined standard values. Here I have already added the numbers for urea and electricity NL, taken from the list of additional standard values. Please note that you should also take over the reference. I have done so here in column T. There is one further comment that I must make here. You must first pay attention on whether the data is per kilogram or per megajoule of the input. This is why the urea data are in columns E, F, and G, and the electricity NL data are in columns I, J, and K. If you would have found data with only a CO2 number and no CH4 and N2O numbers, or you would only have found a CO2 equivalent number, then in both cases you would have filled in the number in columns E or I and put 0 in the other two columns like this. You cannot enter values into columns H and L because these columns are not used in the calculations. Now I can go back to the sugar beet ethanol calculation sheet. To change the nitrogen fertilizer into urea, all I have to do is this. You should make sure that this is the same name as is used in the user-defined standard values. For the electricity it is more complicated. I have to insert a row like this. Then I have to copy-paste information from another row like this. I will put electricity NL into this field here. You can now see that the result has changed and is still almost the same as for diesel. Apparently the emission factor per megajoule is almost the same for diesel as compared for electricity from the Netherlands. You can check this if you like. Of course, we did use much less electricity, 134.5 megajoule per hectare per year like this. We are done now and the calculation is complete. I have to show you one point of attention as to make you aware. I have copied this row for diesel with a unit in megajoule per hectare per year. If I would have copied this row, I would have gotten a wrong result because the unit here is kilogram per hectare per year, and this looks for another number in the list of standard values. I can show you this by looking at the formulas. First, the one for diesel. You see that in the formula a value is searched in the list of standard values. It looks for a number in column 7, in this range starting in column C. For electricity, you see that for CO2 it looks for the same position. For the values in kilogram, like for urea but also for the other ones, it looks for a number in column 3. If you now have a look at the list of standard values, you see that when column C is column number 1 in the numbering included in the list, that column 3 is the column for the emission coefficient for CO2, expressed as grams CO2 per kilogram, and column 7 in the column for CO2 in grams CO2 per megajoule. So in conclusion, when you copy rows in the calculation sheets, you should make sure that the calculations are done correctly. In this case, if I would have copied the wrong row, then you would have gotten invalid results because the emission factors per kilogram of electricity are not defined. I promised another word on track changes. You can put track changes to off and look carefully. If I do so, the for compliance version changes into the for testing version. If I make a change now, like changing a value, like this, or inserting a row and copying formulas, like this, the new or changed cells are no longer marked, as mentioned in the calculation rule document. You can use the for testing version whenever you like, but you should use the for compliance version if you make a calculation to be checked by a verifier. Finally, here you also see that in case copying information leads to an error, you can quickly detect what is the cause by looking at the actual formulas. Cell 51 calculates a new value using this, and this cell, whereas the copied cell E50 uses this one, and this, and this, and this. If I correct this, like this, then you get the same result. You should always make such checks when you copy-paste formulas in the Excel tool.